And we're off. Okay, everyone, I'd like to move on into chapter 10, which deals with inheritance. And like I always like to do, I don't know if I always do it, but I like to explain the importance. So, why inheritance? And I feel like a little bit of a broken record here um, because when we talked about methods, I gave the same answer as to why it's important. As then I said, hey, classes and objects. I said, this is why classes and objects are important. And it really boils down to same answer for inheritance. So why, why study methods and why study object-oriented programming, classes and objects, and why study inheritance? It really boils down to code reuse. And so when I have these advisory board meetings and they advise me to pound the concept into your student's head about code reuse and how important it is, and make sure your students understand that that's why everything is the way it is in C# as far as why we write methods and why we write classes and why we use inheritance. It's all for code reuse. And when you are reusing code, you're more efficient. It's easier to debug and troubleshoot. So you have a problem. It's easier to solve it. And when it's easier to solve problems, that's what programming is all about. It becomes easier to solve problems, and that's what we are doing. We're taking real world problems and solving them by writing software. So that's inheritance. Now, that's the importance of it. But to get into what is inheritance, when all of you think about inheritance, not in a software sense, but in a real world sense, what do you inherit?
Money.
Okay, so I heard two very good answers. You inherit genetics, genes, right? So in my personal genes, my father is tall, and my mother has pale skin, right? So my father and my mother had me, therefore I got my height from my dad and my fair skin from my mother, right? So that makes sense. What about, and I also heard, I also heard money, right? So money would be data, right? That would be some information, but it would be data in our programs. What about attributes? Well, I just gave the answer, like height, right? That would be attribute. Money could be data or an attribute. Okay, so if you can inherit attributes, what else might you inherit in the real world? If we're talking about inheritance.
Eye color.
Huh?
Eye color.
Okay, eye color, so we're still talking genes, but have any of you, like music runs in your family, like the ability to skills and talents, or can you inherit, behaviors, right? Like athletic or musical ability, behaviors, aka methods. So I'm trying to get you to think, well, yes, you can inherit these things in the real world and how they might translate into programming. You can inherit someone's attributes such as their height, or you can inherit the ability to be athletic, or the ability to play an instrument. And yes, those are taught skills. I understand that, but I'm just trying to get you to transition to think, okay, you can inherit attributes or you can inherit methods. So from a coding standpoint, what this is going to allow us to do is we're going to write code. We're going to write code in a class that will become a parent class, or we say or a base class. And when you have code in a parent or base class, you'll be able to inherit that code in a subclass. I guess I'll keep with parent. There's parent and child class, or a base class, you could say, or a derived class. So terminology here, parent is the same thing as base, and then a child class is also a derived class,
the same thing as a subclass too.
which is also the same thing, or subclass. Yes, I guess so. You're right. Base class would tie into subclass.
Superclass is the same thing as base class.
Superclass is also base class. Yes.
Use it all because it's like so many different words for the same thing.
So many different words for the same
Slight
thing.
differences in
Yeah.
one or the other.
But if you can picture, super would be the one on top, right? Sub would be the one on the bottom, right? So there's a hierarchy, right? The top class and the bottom class. And just like in genetics, sometimes your genes, they skip a generation, right? I think they say baldness is like that. So if your grandfather is bald, is a good chance you'll be bald, but it also tends to skip generations. So just like that is in the real world, you can have you can inherit from grandparent classes and great grandparent classes.
If you did that though, wouldn't all the if you had a parent class and then child class and then another child class with that child class, all those attributes and methods
Would all be inherited.
They go up the chain.
Yeah, transitive.
It doesn't actually skip a generation like the
It doesn't skip a generation like baldness. That's a good point. Yeah, it's not like baldness because it doesn't skip a generation. They're all inherited. Okay. So that's some of the terminology, we just kind of discussed there. But we talked about the benefits. We talked about some of the terminology. Talked about some of the things it can inherit. I guess the next thing we just need to do is start coding, since these need to be hands-on demonstrations. I'm going to go ahead and add a class, and I'm just going to use animal. Now animal is going to be my parent class, and the thing about inheritance that is another kind of theoretical concept is the higher you go up the chain, the more generic something is. Okay? So if you think about it in the terms of animal is pretty generic. We don't know, what type of animal it is. It's a very generic thing. However, if I were to have another class, I could add another class called dog, which is more specific than animal, right? And dog can extend with, and this is how you code it, animal. Okay, so this is really all that it takes to have a child class. Child class is dog. Parent class is animal. And you can kind of see that the higher up the hierarchy, the lower in the hierarchy, the more specific. So lower in hierarchy is more specific. Higher is more general. Okay? And just to show you the entire, that we can have like grandchildren and things like that, if I have a pit bull is a breed of dog, so pit bull can inherit from dog. Okay? And the higher you go up the hierarchy, the less you might know about something. But as we get down into pit bull, you can start to understand attributes and methods that this class might have. So let's start with animal. And this is real generic here. So we know that animals might have a number of legs. So let's start by declaring our instance fields. This is like my go-to example. I don't know why number of legs is always my... That's like what I did last time too, right? And let's make a read and write property for number of legs. So we're writing a public. It's going to return integer, num legs. And the get is going to return okay. So we have our public property that can read and write the number of legs inside of animal. But because dog extends animal, therefore dog, let's see if we go ahead and create a dog, what it has access to. So we actually extended the class. You know, we did that by saying public class dog extends animal. Okay, so we actually did that. We're inside of our main method here. Let's go ahead and create a dog. And then we could say rover dot, and look what rover has access to. Is this our field or is this our property? This is our property. Rover dot number of legs equals 4. Now, did you notice we had access? We have access to the property, but not directly to the field, because the field is private. What's it called when we have our fields private but we give them access through properties? That's called data hiding, right? So inheritance enforces data hiding because we did not have access to the field, we only had access to the property. But through that property, we have access to the field. Does that make sense?
Yeah.
Clear as mud. Okay. So, how does this benefit us? Why does it even make sense that we're doing this? Well, now we can generically define the properties that animals might have, and then anything that inherits from animal, we don't have to code those properties again. We don't have to, for example, we said animal dog. What if we had a cat, right? New class cat, not CA. Let's see if it refactors for me. Yes, it does. Okay. Public class cat extends animal. Now, without even coding the cat class, we can go back into our main. What's the name of, anyone got a cat?
Callie.
Whiskers. Now, notice we don't have a number of legs property inside of our cat class yet. We could say whiskers dot num legs. Does whiskers have all of its legs?
No. Make him have 3 legs.
Whiskers lost a leg.
You got in a car accident.
So
Only got 3 legs.
we coded the property once, but many of our child classes. Our child classes have access to those public, and one word that can be used, one word that I haven't used very much in here, you could say members, right? Members are fields, methods, or properties. So when you talk about a class's members, well, the main things are the methods, the fields, and the properties. So when you have public members, they can be accessed through child classes. Now, down here, we also create a pitbull, but because pitbull extends dog and dog extends animal, let's see if we instantiate a pitbull. We're gonna call him King. Do you know I had a pitbull named King? You probably didn't know that about me. Equals new pitbull. And King dot numb legs. It was a long time ago, but he's the king, so he has 6 legs.
That's 6-legged pitbull.
Again, benefit here, code reusability. We code the property once, and it's inherited by all of its children. Now, in animal, we could say something like public void run, or we would just say move. We know all of our animals are going to move. And console.writeLine somehow moving. So we wrote a public method in animal. Now let's see what happens if we say rover dot, there's our move method, except for I don't like that it's lowercase. That's not following our convention. So I'm going to make it a caps. If I say rover dot move and whiskers dot move. Okay, now if I run this, you could see both of them are moving somehow. So they inherited the generic method to move. So that kind of leads me into something I'm not going to talk about on this video, but what if one of our child classes needed a more specific implementation of that move method? You know, for example, the dog could run, the cat could jump high, you know. They all moved a little differently. Whether it's the dog runs fast, the cat runs slow, and the pit bull sprints.
Right, the method is what the child class.
Then you would have to specifically override, and we'll do that tomorrow, where we start talking about overriding, so we can have more specific implementations of methods or properties. Okay, but again, we write the method once, we write the property once. As long as it's public, it can be accessed by its children. So the benefit is code reusability. Let me go down here. So we've explained inheritance. We've inherited code. We've gone over some terminology with super and sub and child and derived. We've extended the class. We've demonstrated the code reusability and how it can make you more efficient, so you're not coding the same thing over and over again. And the last thing is protected. Okay, so there's another access specifier. What are the access specifier we've been using so far? Mainly private and public. Okay, so since animal is our parent class, I'm going to add an access modifier, protected string. We know we're going to give all of our animals names. But because I make this protected, watch what happens over here. So notice before, we have access to the property, but not directly to the field, right? So what if I want to say rover dot, whoops, excuse me. It's only accessible in the child classes. So since dog inherits from animal, let me make a dog constructor. There it is. So you see here we have access to the name field that comes from animal.name. So if we wanted all of our dogs, anytime you instantiate a dog, we name them Rover. So I'm sweating from the coffee. So what's the benefit here? What's the benefit here? Okay, so what have we done? We changed the access modifier from private to protected. Let me write the logic here. Protected access modifier allows access to a member, and I'll just, in our example, we used a field, allows access to a field in the derived class.
You want to give it specifically to pit bull.
Well, same thing, because pit bull inherits from dog. If I made the constructor, you still have access. So, oh man, so what's the benefit here? I need to go back to my original question. What's the benefit here? Well, the benefit, it's easier to code. It's easier to code. That's the benefit, is that you can have access to this field in the child class, and you don't have to worry about having these private fields and these public properties to access them. Well, that's nice that it's easier to code, but it destroys data hiding, right? Because now you have access to your data is your field, and you allow direct access. Remember, the benefit of having a property, the benefit of having the property is we could say, well, you know, public string name get set, you know, we could say, you know, if value is empty, console dot, you could have error detection here. Console write line, bad value, please enter a name. Right? That was the whole benefit of having public properties to modify and access these private fields, was data hiding and enforcing data validation. But if you just mark, I mean, it would be easier, everything public. Yeah, everything's public, right? No security. Just mark everything public. Then anywhere you go, you could set the name. See that? Wouldn't that be easier? Yes, it would be easier. Less secure though, right? So instead of marking things public, our fields are private. Our fields are private. They're accessed through public properties or public methods, either way. Yes, if I change this to protected, if I were to change this to protected, then that field could be accessed in its children. That's how the scope changes. However, is it good practice? Probably not. Okay?
You do it in the children, you can't do it in the main method.
You can't do it in the main method, but you could do it in the children. That's why when I first did this, I went into the main and I was trying to code it, and it's like, no, you can't do that in main. You have to do it in the children. You can access it in the children. But again, this is bad practice. So to keep it simple, it really is fields are marked private. They can be accessed through the properties. Protected is there to make your life a little easier, but best practice. Now, are there scenarios where you might feel you need to use protected? I'm not saying don't use it under any circumstance. It's there for you to use should you need it. However, just keep in mind when you do that, the data hiding principle of object-oriented programming goes to waste, right? It's not being implemented. All right. That's inheritance. That's kind of our intro, and that's where I'm going to stop this video. We'll pick up with the next video tomorrow, and we'll see you then.